Hello everyone, hope you are doing well. I'm Reza, founder of the optimizationct.com. In this session, we will learn how to solve the linear programming model using the graphical methods, and then we will solve the same model with the software named GAMS, a well-known commercial software for solving the optimization model. Finally, we will compare the result of these two approaches. So let's get started. In this tutorial video, we will solve the linear programming model using the graphical methods. We will also solve the same model using the GAMS software and compare the result of the both methods. The model we will work with here is as follows. It has two variables and four constraints. We are going to maximize the 5x1 plus 3x2 subject to x1 plus x2 is less than 60. x1 is greater than 3, x2 is greater than 3, 2x1 plus 3x2 is greater than 3, and we have the non-negative constraint for x1 plus x2. Now let's solve this model using the graphical method. To do this, we first draw the feasible region. The first constraint x1 plus x2 is drawn using the 2 points. Okay, first constraint, we need 2 points. 60, sorry. 6, 0, and 0 and 6. So we plot here. Six, 0, and 0, 6. This is the first constraint. Okay, enter. This is the first constraint. Since the origin satisfied this constraint because 0 plus 0 is less than 6, the feasible region is below this line. So this is the feasible region. The second constraint, x1 is greater than 0, 3 is a horizontal line at x2 is equal to 3. This is x1, this is x2. Okay. x1 is greater than 3, this is here. The feasible region is to the right of this line. So this is constraint number 2, and this is the feasible region. For constraint number 3, x2 is greater than 3. So this is x. This is x2 is greater than 3. And the feasible region is above of this line. So this is constraint number 3 and above of this constraint. The fourth constraint, 2x1 plus 3x2 is greater than 3, is drawn using 2 points. What is the 2 points? 1.50 and 0, 1. Okay, write it. Plot the spline. 1.5 and 0, 1. This is constraint number 4. Since the origin, it means 0 and 0, does not satisfy this constraint, so the feasible region is above this line. So this is the feasible region. Considering the non-negativity constraint for x1 and x2, the first quadrant is the feasible region. Ultimately, the feasible region is reduced in a single point. So in this case, the feasible region is only one point. So we can see that only one point satisfies all constraints. And the optimal solution is this point. What is this point? This point is 3 and 3, and C star is equal to 24. So we have only one point in the feasible region, so that point is an optimal solution. So next, we solve this model using the GAMS software. This is the code. We have green is better. We have two constraints. Sorry about. Oh, okay. We have x1 and x2 constraint x1 and x2 because they are non-negative. So we just write positive variable. Z or objective function or objfu is free sign, so we just write a variable. We have 5 equations. One equation for objective function and the other for constraint. Obj or z is equal to 5x1 plus 3x2. We have 3 sign for inequality. Is less than, is equal to, L equal, greater than, we write in the GAMS code equal, G equal, and equal, we write equal E. So Z or objective function is equal to 5x1 plus 3x2. Constraint number 1, x1 plus x2 is less than 6, x1 is greater than 3, x2 is greater than 3, and 2x1 plus 3x2 is greater than. This is the model. We use the command solve to solve this model using the NLP solver in the maximization form of the objective function. To display the function, we use this command, display x.l or level of the optimal solution for x. So what happened? This is the code. Okay. Right. Okay, and run. You can see that the optimal solution is x1 is equal to 3 and x2 is equal to 3, and optimal solution for objective function is 24. In this slide, we modify the first constraint to x1 plus x2 is less than 5. When we plotted the constraint, only the first constraint changed. The new line okay, this is the first constraint. When we plot the constraint, only the first constraint change. The new line is drawn using 2 points here. 5, 0, and 0, 5. Here you can see that this constraint number 1 would be here. And the other constraint remained same. This feasible region is empty in this case, so there is no feasible solution. There is no intersection between all constraints in this case. So in GAMS, we make the same change to see what happened when we decrease the right-hand side of the first constraint. When we solving here, we change the 6 to 5 and we press the red arrow, and what happened here? So we can see that no feasible return or model infeasible. It means that we don't have any feasible solution for this case. So what happened? This is the model. Now we modify the first constraint to x1 plus x2 is less than 7. In the new plot, the first constraint is drawn using 2 points. 7, 0, and 0, 7. So, okay, this is the first constraint. Seven, 0, 7, and 7, 0. Because the origin satisfies this constraint, so the below of this line would be in the feasible region. So what is the feasible region in this case? So we can see that this triangular would be feasible region. And to find the optimal solution, we evaluate 2 points of the objective function. Okay, z is equal to 7.5. We have 2 points, 1.50 and 0, 2.5. And if z is equal to 15, we have 2 points, 3, 0 and 0, 5. So we plot here for objective function, change the color to red. Okay, okay, 1.5 here, 0 and 0, 2.5. Okay. This is the objective function in this case. So, right. Okay. Z is equal to 7.5. The other is 3 and 5. This. These two lines is parallel, so Z is equal to 15. As the model maximizes Z, the objective function moves upward here. The optimal solution in this case would be here. The parallel line, and this is the objective function. In this case, we have the objective function at point. What is this point? Is x star is 4 and 3, and c star is 29. In GAMS, what happened in GAMS? So we returned GAMS. Okay, this is the model. And we changed the 5 to 7, and we click the red arrow, and this is the objective function is equal to 29, and x1 is 3, and x2 is equal to 3. Well done. This example shows how a small change can alter the feasible region. Here we could visualize the solution because there are 2 variables. What happens when there are more variables? Because please share your thought or idea in comment. We will address this question in the future video. Thank you so much for watching us. If you have any question or need help solving a model, feel free to contact us by email or filling the contact form from our website www.optimizationct.com. Do not forget to subscribe our YouTube channels to stay updated with our video. Thank you so much and goodbye.